A cave in Somerset holds a woman who has been dead for 15,000 years. A cave in Wales, less than 100 miles away, holds a man who has also been dead for thousands of years. They should be neighbors. They should share blood. Instead, when scientists finally cracked open their DNA, they found two people who were not related to each other at all, who did not come from the same place, who did not even eat the same food. And when researchers took what was left of one of them and searched the entire genetic map of Europe for a match, only one region on the continent came back positive. Not Germany, not France, not anywhere near where you'd expect. Stay with this one, because the answer changes what British was ever supposed to mean. This isn't speculation dressed up as science. The individuals at the center of this story were analyzed by the Natural History Museum in London, in a study led by Dr. Selina Brace, working alongside Professor Ian Barnes, one of the museum's senior ancient DNA researchers, and Dr. Rhiannon Stevens at University College London, who handled the isotope work that reconstructed what these people actually ate. Their findings were published in the peer-reviewed journal Nature, Ecology, and Evolution. This is not a documentary built on guesswork. It's built on radiocarbon dating, nuclear genome sequencing, and isotope chemistry pulled from bone collagen that has survived since the end of the last ice age. Both skeletons had actually been sitting in museum collections for decades before any of this was possible. The Somerset remains had been known to archaeologists since the 19th century, and the Welsh remains since 1880, when they were first excavated on the Great Orme headland. What changed wasn't the bones. What changed was the technology. Sequencing methods sensitive enough to pull a usable genome out of degraded material that had spent 15,000 years underground, something that simply wasn't achievable even 10 years earlier. That's part of why this finding landed the way it did. It wasn't a lucky new dig. It was old evidence finally getting asked the right question. Before we get to what they actually found, it's worth walking through what most people already believe about Britain's first inhabitants, because almost none of it holds up. The first idea, the one repeated in pub conversations and old textbooks, is that Britain has always had one continuous population going back to the Ice Age. The "we've always been here" story. It's a comforting one. It suggests a single unbroken thread of ancestry running from the earliest hunters straight through to the people reading this sentence. It's also the weakest of the three theories, and the easiest to dismantle, because it doesn't even survive a comparison between two skeletons found less than 100 miles apart. If Britain's population had truly been continuous and singular, those two individuals should share ancestry. They don't. The genetic record doesn't support a single thread. It supports something closer to a relay race with the baton dropped and picked up by entirely new runners, more than once. The second idea is that the earliest Britons were essentially Proto-Celts, an early version of the Welsh, Irish, and Scottish populations. That would come later. This one is understandable too, since Celtic culture became so dominant in the archaeological record of the British Isles, and it carries a little more surface plausibility than the first theory, but the timeline simply doesn't allow it. The late Upper Paleolithic individuals in this study predate the earliest Celtic-speaking cultures by more than 10,000 years, a gap so large that dozens of generations of total cultural and linguistic change could fit inside it. There is no continuous cultural or genetic line connecting them, and archaeologists have never found one. The third idea, the one with the most going for it, is that Britain's earliest population came from what is now Germany, or the Low Countries, mirroring the Anglo-Saxon migrations that would arrive thousands of years afterward. This is the hardest theory to knock down, since we know later Britain absolutely did receive major genetic input from that direction, and it's tempting to assume the pattern simply repeated itself further back. But applying that later pattern backward, on to people who lived 15,000 years earlier, turns out to be a mismatch on both geography and timeline. The genetic clusters these two Paleolithic individuals belong to don't trace to the North Sea coast at all. One traces southwest, the other traces southeast. Neither one points toward Germany. None of these three stories survive contact with the actual data. And that's exactly what makes the real answer worth sitting with. To understand how researchers can even make a claim like this person's ancestors came from this specific corner of Europe, it helps to think about ancient DNA the way you'd think about a very old, very battered passport. Most of the pages are damaged. Stamps have faded. But certain marks survive intact, and those marks are unique enough that they can be traced back to a specific point of origin. Geneticists call these marks genetic clusters, essentially groups of ancient people who share so many of the same DNA stamps that they must have come from the same founding population, even if the actual individuals never met. When a newly discovered skeleton's DNA lines up almost perfectly with one of these known clusters, it's the equivalent of matching a mystery passport's stamps to one specific country's customs office and no other. Isotope analysis works a little differently, but it plays a similar role in this story. Instead of reading ancestry, it reads diet, because the chemical signature of what a person ate for the last several years of their life gets locked into their bone collagen the same way rings get locked into a tree trunk. A childhood spent eating marine fish leaves a different chemical fingerprint than a childhood spent hunting red deer on open grassland, and that fingerprint survives just as long as the DNA does. Combine the two methods, ancestry from the genome and lifestyle from the bones, and researchers aren't just identifying who these people were related to. They're reconstructing how they actually lived. Now to the find itself. The first individual, a woman, was recovered from Gough's Cave, part of the Cheddar Gorge cave system in Somerset, southwest England. She lived around 15,000 years ago, in the period researchers call the Late Glacial, when the ice sheets covering northern Europe were retreating, and small groups of hunter-gatherers were pushing back into land that had been uninhabitable for millennia. To put that span in perspective, 15,000 years is roughly 3 times longer than the entire span of recorded human writing, stretching back further than the pyramids at Giza by a factor of nearly 3. It's also, put another way, somewhere around 600 human generations standing between her and the person watching this right now. Her mitochondrial DNA belongs to a lineage called Uku8A, a marker also found in Magdalenians. Culture individuals from sites in continental Europe. Her diet, reconstructed from isotope analysis of her bones, was built around red deer, wild cattle, and horse. She was a hunter of the open steppe tundra landscape that still covered much of Britain at the time. The second individual, a man, came from Kendrick's Cave on the Great Orme Headland in Llandudno, Wales, barely 100 miles from Somerset. He lived roughly 13,500 years ago, so close in time to the Somerset woman that, on paper, they could almost have been contemporaries. His mitochondrial lineage was U5A2, a completely different maternal line. His diet was almost entirely marine, built on fish and shellfish pulled from the coast near his home. Different food, different landscape, different mother's bloodline stretching back into the past. Here's the part that turns this from an interesting detail into something much bigger. When the research team ran full nuclear genome comparisons, not just the maternal line, but the entire genetic ancestry profile, they found that these two individuals did not descend from the same source population at all. The Somerset woman's genome clustered tightly with a group known to geneticists as the Goyet Q2 cluster, first identified in remains from Belgium, and statistically her closest known relatives are the Magdalenian culture people recovered from El Miron Cave in Cantabria on the northern coast of Spain. The Welshman's genome, on the other hand, clustered with an entirely different group known as the Villabruna cluster, named for a site in the mountains of northern Italy, representing a population that had been expanding westward out of the Balkans and the Near East. Let's pause and rehook here because it's easy to lose the thread in the terminology. Two people, roughly the same time, barely 100 miles apart on a map that didn't yet have Britain fully connected to the mainland, and genetically, they are strangers, each one belonging to a separate wave of humanity that arrived in Britain from a completely different direction. One traces back toward Iberia, one traces back toward Italy and the Balkans. If you were building a family tree of early Britain, you wouldn't draw one trunk. You'd draw two roots growing from opposite ends of the continent, only for their branches to briefly cross paths on this one small island. If you're finding this as fascinating as we do, this is exactly the kind of story this channel exists to tell, so consider subscribing before we go further, because the reveal that comes next is the part that actually made headlines. Once researchers had the Somerset woman's genetic profile locked down as belonging to the Goyet Q2 cluster, they didn't stop there. They ran her data against genetic reference populations spanning the length and breadth of the European continent, from Scandinavia to the Balkans, from Ireland to the Russian steppe, checking for any surviving trace of that specific ancestry pattern anywhere else on the map. Across almost the entire continent, the signal simply wasn't there. Populations across most of modern Europe carry ancestry from later migrations that swept over and diluted anything resembling the Goyet Q2 signature almost to invisibility. Only one region returned a genuine, statistically strong match: the Franco-Cantabrian corner of northwestern Iberia, he belt of coastline and mountain running through what is now northern Spain and into the Basque region and southwestern France. Researchers cross-checked this result using multiple statistical methods rather than relying on a single test, running both direct allele sharing comparisons and formal admixture modeling, and both approaches converged on the same answer independently. That kind of agreement between separate methods is exactly what gives a finding like this real weight, rather than letting it rest on a single ambiguous statistic. That is the reveal the title promises, and it's worth stating plainly. Britain's very first securely dated genome, a woman living in what's now Somerset 15,000 years ago, traces her deepest ancestry not to anywhere else in Britain, not to Germany, not to Scandinavia, but to the far southwestern tip of Europe. the same refuge zone that would centuries later become associated with one of the most genetically distinctive and famously isolated populations still living in Europe today. During the depths of the last ice age, when most of the continent was buried under ice sheets, human populations survived by retreating into a handful of warmer pockets, and the Franco-Cantabrian coast was one of the most important of these refugees. And when the ice began to retreat, people moved back out from that refuge in waves, recolonizing the land the glaciers had abandoned, and the Somerset woman's ancestors were a part of exactly that outward wave. Archaeologists had already suspected something like this from the stone tools alone, since Gough's cave contains a mix of late Magdalenian and Federmesser-style technology, a toolkit tradition with deep roots on the Iberian side of the continent. The DNA didn't contradict what the artifacts were already hinting at. It confirmed it and gave the hint a name. Here's where it gets more interesting rather than less. The Welshman from Kendrick's Cave, remember, didn't match that same refuge population at all. His Villabruna ancestry points toward a completely separate recolonization wave, one moving out of the Italian peninsula and the Balkans, rather than out of Iberia. And by the time we reach the British Mesolithic, several thousand years later, it's the Villabruna-related ancestry, not the Iberian-related Goyet Q2 ancestry, that dominates the genetic record of Britain almost completely. There is exactly one known exception, and it's a famous one. Cheddar Man, also recovered from Gough's Cave, who lived roughly 10,000 years ago and carries a genome that is mostly Villabruna-related, but with a lingering 15% trace of that older Goyet Q2 signal, a faint genetic echo of the Somerset woman's, population still detectable thousands of years after her death. What makes this so remarkable is the scale of turnover it implies. This wasn't one migration into an empty land followed by quiet continuity. This was wave after wave of population replacement, each one arriving from a different corner of the continent, each one leaving Britain's genetic map looking almost nothing like it had a few thousand years before. Professor Ian Barnes, who led the ancient DNA analysis at the Natural History Museum, has been direct about just how disconnected these ancient people are from anyone living today. 5. That is the number his team puts on it. At least 5 separate population replacement events in Europe alone, between the time the Somerset woman was alive and the population of Britain as it exists right now. Let's stack up where we are before moving on. 2 skeletons, barely 100 miles and roughly 1,000 years apart. One woman tracing back to Iberia, one man tracing back to Italy and the Balkans, one dominant ancestry line eventually winning out across Britain except for a single 15% echo surviving inside Cheddar Man himself. And now, a number 5, marking how many times the entire genetic map of this island got redrawn. None of this was assumed. It's also not a lone claim sitting on one paper. The Iberian refuge origin for Goyet Q2-related populations and the later dominance of Villabruna-related ancestry across Britain had already been independently mapped in earlier ancient DNA work, including the 2018 study of Cheddar, Man himself, conducted by many of the same Natural History Museum and UCL researchers. That earlier study is what first flagged the 15% Goyet Q2 trace sitting inside an otherwise Villabruna-dominant genome. A detail that only made sense once the Somerset woman's own genome was sequenced and gave that 15% a name and a place of origin. 2 separate rounds of sequencing, years apart, converging on the same story. That's triangulation, not coincidence. In the next part of this, we go straight into what that number actually means for anyone trying to trace a straight line back to these people. There's also a question worth sitting with before we get too carried away with the excitement of a match. What does it actually mean when scientists say an ancient British genome matches a modern region of Europe? It does not mean the Somerset woman's direct descendants are walking around Cantabria today, and it does not mean anyone from that region can claim her as a personal ancestor. To be clear, this is population-level genetic evidence, not individual-level proof of any modern lineage. What the match tells us is that the deep ancestral population she belonged to, the wave of people expanding out of the Franco-Cantabrian refuge after the ice retreated, left its clearest surviving genetic signature in that specific region of Iberia, more than in any other tested population across the continent. It is a statement about where an ancestral population's genetic fingerprint still shows up most strongly, not a statement about unbroken descent from that individual, specifically to any living person today. Given the 5 or more replacement events Professor Barnes describes, nobody is claiming direct genetic continuity between the Somerset woman and modern Britain, or modern Iberia, for that matter. The honest picture is layered and messy, not a single clean line from her to anyone alive now. That honesty is actually what makes the finding more interesting, not less. Britain's story was never a straight line. It was a series of arrivals, each one distinct, each one erased or absorbed by the next, leaving only fragments like the Somerset woman and the Welsh man behind, as evidence that these earlier chapters happened at all. It's also worth being precise about what wasn't tested, because that matters just as much as what was. Nobody has sequenced a continuous chain of individuals linking the Somerset woman to any specific person or family living in Cantabria today. What exists is a comparison between one ancient genome and a set of modern and ancient reference populations spanning the continent, and out of that entire set, the Franco-Cantabrian signal came back strongest. That is a real, measurable, statistically supported result. It is not the same thing as a family tree with her name at the top and a living address at the bottom. Ancient DNA research has been misused before by people eager to draw straight lines from a single skeleton to a single modern nationality, and the researchers behind this study have been careful, publicly, not to make that mistake. The population that shares the strongest surviving genetic echo of her ancestry is not the same as her descendants. 15,000 years ago, a woman walked the open tundra of what would become Somerset, hunting red deer and wild horse under a sky that had only recently stopped being buried under ice. She had no way of knowing that her bones would end up in a cave system that people would still be exploring 15 millennia later, or that a laboratory would eventually read her DNA like a passport and trace her family's journey back to a warm refuge on the far edge of the continent, the one corner of Ice Age Europe, where humans held on when almost everywhere else went silent. She was not the ancestor of the people who live in Britain now. She was something else, something rarer in a way. Proof that this island has always been a meeting point, a place where different routes kept arriving from opposite directions of a continent, briefly crossing and moving on. She never crossed paths with the Welsh man from Kendrick's Cave, and she certainly never knew that a stranger from the opposite end of the continent would end up sharing this same small island with her descendants' distant successors. But that's the quiet truth sitting underneath this whole story. Long before there was an England, a Wales, or a Britain in any sense we'd recognize, this stretch of land was already doing what it would keep doing for the next 15,000 years, pulling people in from every direction the sea and land allowed, then asking them to share ground with whoever had arrived before them. If this is the kind of history that pulls you in, the kind that gets rewritten every time, the DNA gets better at speaking, make sure you're subscribed, because these reveals keep coming. So here's the question worth leaving in the comments. Which one surprised you more? That Britain's two earliest known people weren't related to each other at all, or that when scientists searched the whole of Europe for a match, only the far southwestern corner of the continent, not Germany, not France, not anywhere in between, came back as the one true fit?